Good afternoon, Star people, and welcome to the 8th flight test of Starship. It's currently 5:01 p.m. Central Time here in Starbase, Texas, and we're looking forward to tonight's launch of the world's most powerful rocket. Great view there of the vehicle on the pad. I'm Kate Tice, Senior Quality Systems Engineering Manager here at SpaceX.
And I'm Dan Hewitt with SpaceX Communications. Welcome to our second ever broadcast from Starbase's new Star Factory building. First, if you don't count Monday. But we are at T-minus 28 minutes, 20 seconds, and counting down to a liftoff at the open of our window at 5:30 p.m. Central Time today.
3 days ago, we stood down from a launch attempt after triggering a few holds during the count, which had us hold at T-minus 40 seconds for several minutes, resume the count, and then trigger another automated hold. The final item that ended the day was when we encountered lower than acceptable pressure on the ground spin start system for 2 of the outer engines on the Super Heavy booster. All Raptor engines use high-pressure gas to start up, and we use gas stored on the ground side to start up the 20 outer engines on Super Heavy. By the time this automated hold appeared and the team started to work through it, we also triggered a hold on the booster LOX levels and had to call it for the day.
We were able to trace the spin system issue to just a misconfig on some of the ground hardware, so that had a really straightforward fix. We just took the time, though, to look into some of the other items that resulted in holds throughout the count, including some of our automation was triggering holds on the booster, which we were able to actually clear during that launch attempt by confirming the hardware was healthy, and we had some manual commanding backups. We also looked at some pop-up hardware and software issues on the ship, and just to put us in the best possible spot for a launch today, we destacked Starship, did some repairs inside a ship, and then ran some additional checkouts.
And that brings us to today, just about a month and a half after our last flight, which saw the second ever tower catch of the Super Heavy booster and the first flight of our upgraded ship, which unfortunately ended much sooner than we had hoped. It's important to remember that in development programs like this, progress is not always linear, and there is no comparison to putting flight hardware in a flight environment to learn as fast as possible. We always want to be in the best possible position to achieve our mission objectives, which is why we stood down from launch on our previous attempt and took the time over the last few days to get ready for launch.
Now, the objectives for today's flight going to look very similar to Flight 7. As always, primary payload for these flight tests is data. We are planning to deploy some simulated Starlink satellites and fly a range of experiments focused on reentry. We removed a whole bunch of tiles again from the ship for reentry testing, looking to really stress test it.
We'll also be intentionally stressing the flaps during reentry so we can test the limits of ship before we get ready to attempt future ship catches. So there is a lot of new testing happening today, and as always, excitement is guaranteed.
Now, just a real quick status check. So you could tell we're loading prop onto the vehicle. We're able to get through our prop load go, no go just about 40 minutes ago. And we are loading liquid oxygen, liquid methane on both vehicles, not tracking any vehicle problems, issues on either booster or ship. Weather is green right now. Winds at the pad are actually significantly lower than they are even just for us over here at the Star Factory. Just a couple mile difference makes a big change in those wind speeds. And range is currently projected to be go, but we are always watching any boats that are out there in the ascent and the entry. Now, let's take a couple of minutes to meet today's vehicle. Sitting there on the pad, it's the world's biggest rocket, Starship.
Starship consists of 2 stages, the ship, which has 6 Raptor engines, and the Super Heavy booster, which has 33 Raptor engines. Both stages are fully reusable. Super Heavy is the most powerful rocket ever flown and is designed to launch, return, and refuel, and launch again with 0 refurb between flights.
And then everything else you see around Starship, we refer to as Stage 0. That includes the towers. We've got our second launch tower stacked on the left side of your screen there, getting ready to come online later this year. It also applies to orbital launch mounts, our quick disconnect systems, everything on board. Also the water-cooled flame deflector, which is right underneath Starship. That's a particularly cool piece of engineering. It uses several 100,000 gallons of potable water to offset the pretty intense heat pressure coming out of those 33 Raptor engines at the bottom of the Super Heavy booster at the time of liftoff.
Now, you mentioned engines. Of the 6 Raptor engines on the ship, 3 of those are optimized for sea level performance and the other 3 for vacuum. Raptor Vacuum, or RVAC, well, those have a larger exhaust section and expansion nozzle to maximize efficiency in space, as there's no atmosphere up there. The ship as a whole is designed for vertical takeoff and landing on any hard surface.
The ship itself has 4 flaps that are used to control its attitude and enable precision landing during subsonic flight. And then for full reusability, the ship has to survive re-entry not just once, but multiple times. It does that by using that heat shield, which is composed of those thousands of hexagonal ceramic tiles, which can insulate the vehicle during re-entry, temperatures spiking up to about 2,600 degrees Fahrenheit in some spots. And a rapidly reusable heat shield has never been flown on any vehicle in history, so continuously improving the one we have, Starship, is still a key focus of our flight test campaign.
And of course, in between our first and second stages is our hot stage. Hot staging is when the second stage engines ignite while still attached to the first stage. There you can actually see a video of our previous hot staging maneuver, or executed on a previous flight, and how the ship's engines light while it's still ignited while the booster's engines are still firing. Basically, the rocket never stops accelerating, which makes it more efficient than traditional stage separation.
And then after we launch the booster, we also have to catch the booster, and we do that by using the 2 robotic arms, the same ones that lift Starship onto Super Heavy before we launch. They also catch the booster when it returns. It means we don't have to have any landing legs in the booster. That's a lighter booster. It means we can put more payload, more stuff going to space.
Thousands of criteria must be met before the booster can return and be caught. It requires a healthy systems and manual commanding from the flight director.
And just like on our previous flights, if that command's not sent before the end of the boost back burn, or if those automated health checks running in the background find any unacceptable conditions on the booster or the tower, they'll kick us out, and the booster can default to a landing burn and a soft splashdown out there in the Gulf.
Yeah, we've said it before, we'll say it again because it still holds true today. We accept no compromises when it comes to ensuring the safety of the public and our team, and the booster return will only take place if those thousands of conditions are right. So as the clock continues to tick down to launch, let's say hello to Chris, who's once again posted up in Hawthorne. How's it going, Chris?
Hey, Kate and Dan, and welcome everyone to Hawthorne, California. As you can hear and as you can see, the crowd is gathering. Excitement is really building here for Starship's 8th flight today. And speaking of flight, let's talk about the Raptor engines, which have quite a workout ahead of them today. Now, our Raptor engines are designed and manufactured right here in Hawthorne, and they have certainly accomplished some impressive things already. They've powered Starship in its first few flights around Earth, and they've helped bring 2 Super Heavy boosters back for a catch by the Mechazilla system at the launch site. But here at SpaceX, we're always looking to improve our designs, and we do this by using something that we call the algorithm. Now, for Raptor, the algorithm has helped us question the requirements for the engine, find the parts that we don't need, and then optimize the design for manufacturability and reuse. This allows us to simplify designs and drives us toward that rapid, reliable reuse. And as you can see on your screen here, it is definitely what we have done with the Raptor engine. Look at that beautiful family photo. You can really see how Raptor 3 is an unprecedented step forward in design. It eliminates the parts we don't need. It moves a lot of stuff inside the engine. And one thing that it also allows us to do is to delete the heavy engine heat shields that are used on the current version of Raptor today. And what that means is that when we switch to the Raptor 3 engine later this year, we'll be able to save about a metric ton of mass per engine. And when you multiply that by 39 or more engines, that's a lot of mass. And that mass savings actually helps us increase Starship's efficiency and the amount of payload that we're able to deliver to space and to Mars with Starship. But before we get to Mars, we still have a lot of important and critical development work to do. And it's flight tests like today's that help us do just that. Needless to say, the Raptor teams here in Hawthorne are very excited for today's flight and to see their hard work fly, just like all of our Starship teams are today for Flight 8. So Dan and Kate, back to you for some more info on Flight 8.
Thanks, Chris. You mentioned development. Let's talk about things that we learned from our last Starship mission. In January, Flight 7 of Starship generated lots of important data. That data led us to change some of our pre-flight testing for today's flight. A major find from Flight 7 was the detection of a harmonic response that was much stronger during flight than anything we had seen during testing.
That's right. Rocket engines create incredible amount of noise, vibration that can pass through every component in the rocket itself. Flight 7, we saw those vibrations at a specific frequency. They were also strong in a strong enough amplitude that it was placing a lot of extra stress on some of Starship's propulsion system. And that's what most likely led to propellant leaks that then cascaded into fires and ultimately our loss of contact with the ship.
As part of our investigation, our team took this flight's ship through a 60-second static fire, which was 10 times longer than any previous static fire. The test cycled through throttle levels to recreate different conditions seen within the propulsion system during flight. You can see that on your screen now. We also tested hardware changes on fuel feed lines to Raptor's vacuum engines.
The additional data we got from this test specifically led to some new hardware that's installed in the RVAC fuel feed lines, which are also unique to this upgraded version of ship. Those feed lines look like large straws. They run through the oxygen tank, and those are delivering fuel directly to those vacuum engines. The new hardware was successful in significantly lowering the strength of that harmonic resonance and relieving the extra stress on the prop system. And then just in addition to new hardware, we made a couple of operational tweaks, adjusting things like the temperature of the propellant as it's being fed to the engines, also changing the throttle level that we're setting those engines at on ascent.
We also looked at where fires broke out in the attic, which is the unpressurized space between the bottom of the ship's liquid oxygen tank and the engine heat shields. Fires here resulted in loss of ship on flights 2 and 7, so we took steps to make it more resilient to leaks. We added a hefty purge system that uses gaseous nitrogen. Similar to the carbon dioxide system on the booster, it floods the zone with an inert gas to help prevent a fire.
Yeah, we also increased the attic's just natural fire defense. We added some more vent holes that helps to keep that attic pressure close to vacuum. As Starship flies into space, makes it harder for a fire to ever exist. And then on the next generation ship, we're going to do the best thing possible and just start deleting some parts.
Yeah, the best part is no part.
The next generation of ship is going to use Raptor 3 engines, which are going to reduce that attic volume, and they're also going to eliminate most of the joints on the engines themselves that can leak into the space.
In the end, these changes represent the core of our test program. We fly hardware in a real-world environment, learn from the data, make updates, and fly again.
And then today we're going to be attempting to do everything that we didn't get to do on Flight 7. So we're still looking to get our first re-entry with the upgraded ship, while we're going to be really intentionally stressing it again to get data on what the vehicle's boundaries are. So everything we've got ahead of us, as always, starts with liftoff, and that's super heavy, igniting those 33 Raptor engines, lifting off from the pad here at Starbase for that initial ascent. All 33 will burn for the first roughly 2 minutes before we get into hot staging.
For hot staging, the second stage will ignite its engines while still attached to the first stage. That will create that stage separation. The booster will perform a flip maneuver and head on back to the launch site here just behind us. Then we will hopefully see the third ever tower catch by the launch tower.
Meanwhile, ship completes its ascent burn, gets into its suborbital trajectory. We've got some extra things we're going to do in space, like deploy those Starlink simulators. Also going to be relighting one of the Raptor engines, one of the sea level engines, before we get into re-entry.
Yeah, that re-entry phase will test multiple experiments, including missing heat shield tiles, metallic tiles, and loading the vehicle's flaps. The ship will then perform a flip maneuver and hopefully achieve a soft water landing as we have seen before. We've got some buoy cams stationed out there to give us great daylight views of that splashdown in the Indian Ocean.
Yeah, it's a lot, but again, we're really focused on finding what are the real world limits of Starship. We're doing it in this very remote area to find those limits before we get ready to return ship to the launch site and eventually catch it. And a lot of the upgrades we made to get to this version of ship are going to enable that.
Yeah, man, that's going to be exciting to see Ship catch.
It's going to be wild.
Now, Ship 7 premiered a huge block of upgrades to add more capability to Starship, and we've carried them through to test on Flight 8 today. First, the forward flaps got a redesign. They have shrunk and shifted away from the ship's belly or the heat shield. You can see that on your screen there. This new position will reduce their exposure to heating during re-entry. We've also extended the length of Starship, and we've done this by 2 meters. This additional height gives us about 25% more propellant volume, which will aid in future longer duration missions. We also implemented propulsion upgrades, such as new fuel feed line system for the Raptor vacuum engines, as well as vacuum jacketing of feed lines and an improved propulsion avionics module.
And you've heard us talk, a lot of the experiments we're running today are focused on reentry. We're intentionally removing a whole bunch of tiles all over Starship itself in this missing tile test. They're removed in critical areas this time, including over those propellant tanks, around some of the flaps, as we're really looking to use this flight to push Starship's capabilities. If we're not resilient to a missing tile and the backup ablative underneath, we need to know that. We also test a couple of different tiles on Starship, some metallic ones, one of which has some active cooling built into it.
Avionics also underwent a complete redesign with 4 upgraded Starlink terminals. You can see the location there popping up on your screen. Those now combine Starlink navigation and radio frequency, as well as communications into a single unit. And non-structural versions of the ship's catch fittings have been installed to test thermal performance, i.e. do they survive re-entry, along with a smooth and tapered edge on the tile line to address hot spots we covered and saw in Flight 6.
And we've got some radar sensors on the tower catch arms again, as we're just looking at different ways to measure distance between the arms and a vehicle. These ones are actually protected by kind of a modified version of our heat shield tiles. Catching the ship's going to be a little different from catching a booster. One of the key things is it's going to do that flip right before its landing burn that rapidly reorients your antennas, which you're using for navigation. So those extra sensors on the ground side help just add more layers of control as ship and tower talk together for the catch.
And in another first, Starship will deploy 4 Starlink simulators. They are similar in size to our next generation Starlink satellites. Starship will have the ability to deploy our advanced V3 Starlink satellites, which will help further Starlink's impact in the coming years as we work to expand access to high-speed internet all around the world.
Each Starlink V3 launch is planned to add about 60 terabits per second of capacity to the Starlink network. To give you some perspective, that's about 20 times the capacity we're adding right now with every V2 mini launch on a Falcon 9. Those Starlink simulators that we're going to deploy are on the same suborbital trajectory as Starship itself. They're expected to demise upon entry. Starship's trajectory looks super similar to our last couple of flights. Splashdown is targeted for the Indian Ocean. And then on top of all of that, again, we are planning to relight one Raptor engine while in space. That just helps us get data on the in-space burns and show Starship is capable of deorbiting.
Speaking of deorbiting, thanks to Starlink, one of the hallmarks of the Starship missions are the incredible views that we get throughout flight, and especially during reentry, as evidenced by many a phone and desktop background around here. Yeah. Every day, we're working to expand the Starlink network both on Earth and in space. For how this all connects us to the big mission, let's head back to Chris.
Thanks, Kate. Personally, I love all those epic views of the plasma wrapping around Starship during re-entry. Can't wait to see that later today. And fans of Starship may know that Starlink enables us to bring you lots of unprecedented views, both from space and here on Earth. Starlink is the world's largest satellite constellation operating in low Earth orbit today to deliver high-speed, low-latency broadband internet and connectivity, specifically for missions like Starship today. And as you can see on your screen, Starlink brings us many other views because of its capabilities. In addition to the dozens of cameras on Starship itself, we have mobile camera kits with Starlink deployed in the Indian Ocean, which is what you're seeing some footage of right now on your screen from a previous mission. You'll notice the Starlink mini dish in the foreground here as Starship lands in the background. Just what an image that captured from an earlier flight. Now, Starlink also connects our aerial and cinematography units on the ground at Starbase, which will help us deliver the incredible drone shots leading up to launch today. And here on your screen, you can actually see us moving the flaps, preparing Starship for flight, making sure all of the aero surfaces that need to move during flight can do so in the way that we need them to. Now, on Starship itself, Starlink will enable Starship today to stream more than 120 megabits per second of real-time, high-definition video and telemetry in every phase of flight, including views like you're seeing right now of those flaps moving. This not only helps provide those views, but it also helps give our engineers an incredible amount of data to help us rapidly and iterate across all parts of the system as we move through our development program. And all of the streaming data today will definitely be put to good use with the more than 30 cameras on the vehicle for flight. But providing epic views is sort of a side quest for Starlink. Its main job is obviously to provide internet access for people around the world, many of whom who have never had connectivity before. Now, today, Starlink serves more than 125 countries, territories, and other markets with over 5 million active customers and counting. And there are just so many inspiring ways that people are using Starlink all around the world and in space. And hopefully today, in a few minutes, everyone will get to see more inspiration about what our future in space looks like. And Dan and Kate, how are we looking for Starship's flight today?
Thanks, Chris. We are looking forward to those views as well. In fact, we're getting ready to launch Starship in just over 8 minutes. Now, as for a couple status updates, working no major issues on the vehicle. Range is emerald green, you could say. Everything looks great in terms of the sea and airspace here in the Gulf of America, as well as in the Indian Ocean. Of course, we want to make sure both areas are clear as the ship will be splashing down in the Indian Ocean while the boosters can be coming back to us at the launch site just a couple miles behind Dan and I. Weather, you could call it a silver lining that we had to delay from Monday because holy moly, visibility is 1,000 times better today and it's going to make for some really great views. Now leading up to today, we did stack the vehicle later last night. Flight controllers reported to their consoles earlier today. The site was cleared and the range team was deployed.
That's right. And a lot of checkouts have happened just throughout the day, aligning our guidance, navigation, control, getting all the tanks ready for prop load, which has about 4 minutes left to go. You can see us almost topping out on ship, getting ready to top out on booster. And then it also includes getting all the ground support systems checked out, ready to go. Chopsticks were demated, did their wiggle test in advance of their upcoming catch opportunity. So as I just said, prop load's ongoing. We've got a little over about 4 minutes left until, or about 4 minutes. What's 7 minus 4? 4 minutes until we get to closeouts on ship and on booster. We did just hear that the range did pull again green. So we're not tracking any issues right now. Bottom line, things are looking great for launch at the top of our window at 5:30 p.m. Central Time.
Yeah, very exciting. Now, once again, we are attempting to catch the booster at the launch tower. If that happens today, it will be the third ever booster catch. This is an aspect that I really enjoy, and it's how the vehicle announces that it is back.
It lets you know.
Oh, yeah. This comes in an audible sonic boom in the area around the return location, which occur when the booster slows down from traveling at supersonic speeds. Similar sonic booms were heard during the return and landing of NASA's space shuttle.
Yes, sonic booms are unique to vehicles returning from space. They're kind of a hallmark of reusable systems like our Falcon 9 rocket and Falcon Heavy. General impact to those in the surrounding area is that brief thunder-like noise. I've been fortunate enough to be here for all of them so far. They definitely let you know the vehicle's coming. Here's a little bit about what it's like to experience it.
And as someone who grew up hearing those sonic booms as the shuttles landed in Florida and now hearing them for Falcon and Starship as well, they really are something to experience. And when you hear them, you just know it's a spaceship telling everyone that it wants to be reused. Great sounds. So as you can hear, the room is getting excited here in Hawthorne. The crowd eager to see Starship fly, as you can see. And here, now behind me in our flight control room here in Hawthorne, you can see some of our folks on console. They're assisting the flight controllers in Starbase, keeping an eye on all of Starship's various systems, including its avionics and those Raptor engines we talked about a little bit earlier. So Dan and Kate, with 4 minutes, 20 seconds left on the clock, let's hit it back to you at Starbase and hopefully watch Starship lift off today.
Thanks so much, Chris. Now, if you're just joining us, we're now just about 4 minutes until the liftoff of the 8th test flight of Starship. As we reported earlier, range and weather are both very green, super green, if you will, and everything is looking good. Propellant loading continues to happen. We're going to be closing out very soon on both stages of Starship.
Yeah, we're almost fully fueled on our tanks. We're going to see that closeout coming in just about 30 seconds on ship. So that's both the main and the header tanks. And then about 30 seconds later on booster. Once prop load is complete, we got just shy of 1 million pounds of liquid propellant. That's liquid oxygen, liquid methane onto both vehicles. All of our ground systems will do what's called pushbacks. They'll clear all those feed lines. We're not continuously replenishing the propellant on board Starship or Super Heavy. That's why we essentially have several minutes where we can hang out at that T-minus 40 hold point before we start to run into issues with temperatures or just those LOX levels, or that LOX level on the booster is one of the main things that we watch. So we're also going to do a couple of final checkouts. We'll do one final one of the thrust vector control, the TVCs on the booster. We'll see them hopefully do a little bit of a wiggle test. The first one comes at about 1 minute 40 seconds before launch, and then the last one comes right as we pass that T-minus 40 gate. Again, if we need to hold, which we held a couple of times on Monday, we can do so at that T-minus 40 second. We're not currently tracking any issues that would hold us there, but if we do run into that, we can hang out for a couple minutes.
That would be the point in the countdown, as we mentioned on Monday. That T-minus 40 second point is when we can pause to hold for final checkouts or pressurizations if necessary. But once we pass that T-minus 40 second mark, a number of things are going to occur in rapid succession. The ground spin and ignition systems will come up to flight pressure. The ship goes to internal power. And after that, the quick disconnect or QD arm lockout, that's removed in preparation for retraction shortly after T0. Once we pass T-minus 40 seconds, as we saw on Monday, we had the ability to recycle the count under certain conditions back to that T-minus 40 second mark and hold there to assess what happened and if we're able to proceed to T0.
And like we said, that we can hang out at T-minus 40 for several minutes before we start running into some limits, essentially. On our propellant on board. There are a couple of other things, like if we pass the T-minus 10 second point and the water starts to flow in that flame deflector and we scrub, that's automatic scrub for the day. Oh, there's our TVC, our thrust vector control checkout. It's got a little bit of a wiggle there on those inner Raptor engines, those 13 inner ones, which are going to be used for that boost back burn and the landing burn. So cool to see those.
Yeah. I love that shot. We don't have that on Falcon. And it's just so cool to see really the business end of the Super Heavy booster.
Ten seconds away from that T-minus 40 hold. We'll see. All right, we are going to hold at T-minus 40. We're watching the temperatures on the ship right now for the ship fuel. Sounds like they're working through that. We might be able to release that hold shortly. All right, sounds like we're going to be able to reset those holds, not tracking any other holds. And clock is rolling.
And the clock is rolling once again. We're now T-minus 30 seconds till the liftoff of the 8th flight of Starship.
All Our flight director, Joe Schleicher, today is go for launch. Let's listen in as he takes us through the final seconds of the count.
T-minus 8, 7, 6, 5, 4, 3, 2, 1. We got liftoff. Vehicle pitching down range.
Little over 40 seconds into the flight. We are seeing 33 out of 33 Raptor engines ignited. Boosters pushing us downrange over the Gulf. Next milestone coming up in just under 10 seconds is going to be max Q, that max aerodynamic pressure.
Max Q.
All right, so we're through max Q. That's the heaviest stresses it's kind of seeing on the way up. Wow, that was pretty incredible.
I'm still recovering. That was amazing. Beautiful views of the vehicle on ascent, pitching downrange away from the launch tower.
Next thing coming up is hot staging. So we're going to look for 6 engines to ignite on ship while we're still attached to the top of the booster. We'll see all but those 3 center engines shut down on booster.
We're hearing the initial call that we are go for booster catch back here at the launch tower. Coming up now on hot staging, the ship's engines will ignite while still attached to the Super Heavy booster, and also while Super Heavy booster will still be under power itself. The clamps holding the 2 stages together are going to release, and Starship second stage engines will
Booster
ignite.
engine cut off. Ship engine startup. Stage separation. Boost back burn startup.
There we go. Ship engines, all 6 Raptors ignited. We're doing that boost back burn. Looks like we got 11 of the 13 that we command for that, so that's going to start sending the booster back. We are still go for booster return, even with 2 Raptors out during that boost back. We can do a full duration one. But
chamber push is nominal.
Looks like we got a ship, 6 engines heading into space, and then we got a booster hopefully on our way back to Starbase. How's everything going in Hawthorne, Chris?
Everything is looking good. The crowd eagerly followed that ascent and now watching the booster coming back. So as you can see on the left-hand side of your screen here, that is ship continuing. And that's a great view of ship continuing on its way to space. They're looking, that's inside the camera, inside the aft skirt, looking at the Raptor vacuum and the sea level engines, the sea level ones there in the center of your screen under our T+ clock. You can see our boost back burn. We're down to 3 engines on the boost back burn. And you can see ship on the right-hand side of that telemetry with 6 engines lit, continuing its ascent to orbit, already over 100 kilometers in altitude. The booster 87 kilometers in altitude and continuing its trek right now back to the landing site and catch site. There's a shutdown. And we just heard a good call out for boost back shutdown. The next thing we should see on our screen is the separation of the hot stage from the Super Heavy booster. We jettisoned that because we do not need it for the landing, but on future iterations of the Super Heavy, that hot stage ring will be incorporated into the booster and we will get it back. But for today, you can see it on the right-hand side of your screen there, just separating off from the right-hand side of the booster. You can also see the booster doing its liquid oxygen dump there, which is exactly what we would expect for it to do as the booster gets itself configured for the landing here. Now, meanwhile, Starship will continue to coast after it reaches orbit for about 40 minutes or so, up to an altitude of 214 kilometers, but it's still got a ways to go there, currently accelerating past 7,500 kilometers per hour there in velocity. And just look at those great views of the booster coming back. The Gulf coastline there just looks absolutely gorgeous.
Starship is on a nominal trajectory.
And there we hear nominal trajectories all around. And Dan and Kate, we're at 5 minutes, 15 seconds here into the flight. Everything looking good for the Super Heavy and for Starship today. What's it like there at Starbase as we get ready to catch?
It was incredible, Chris, to be able to see the mock diamonds with my own eyes. That was amazing. We are standing by for return of booster back to the launch tower. We have heard that we are go for the catch of the booster.
Yeah, this coming from one of our long-range tracking cameras, we're able to see the hot stage separate and fly away. So coming up in just about 30 seconds, we're going to look for the landing burn. We're going to command those 13 inner and middle ring engines to turn on. 13 initially, they bleed off all of that velocity as we're slowing down from supersonic speeds, eventually moding down to only 3 engines for that precision flight into the tower.
Right now, booster using its 4 hypersonic grid fins to help guide itself through this atmospheric entry back for its precision landing at the launch site. Once again, we're going to ignite first the center 13 engines. We should see that coming up here momentarily.
Engines in startup.
This is going to come down to 3 engines as the booster slows down for its landing. And we just heard the sonic boom. What an incredible sight to see the Super Heavy booster gliding down into the chopstick arms once again.
Thank you very much for the booster.
Stuck the landing.
Wow. That will never get old.
All right. We saw 12 out of 13 light for that landing burn. Booster still able to make its way with that final precision burn on the 3 engines in for the tower catch. So booster caught. Meanwhile, keeping an eye on ship. Still got 6 Raptors burning. Those are going to continue for about another minute until we'll get to the Starship engine cutoff. Really cool view. Again, a million shout outs to all of our avionics team who make these cameras possible for us. That's looking right down inside essentially the skirt area of ship, where you can see a pretty good view of all 6 Raptors, especially those 3 inner ones, one of which we're going to hopefully relight a little bit later. And we just saw some engines go out. It looks like we are losing attitude control of the ship.
Ship FTS is saved.
So we're still getting video down from the ship. You can see we've lost several engines and we've lost attitude control of the vehicle. So we'll continue to stick with it.
For those of you that have For those of you that just recently joined us, we had a successful liftoff of the 8th test flight of Starship, followed by a successful stage separation. We saw the booster, actually, you can see it just behind us here. The booster had a successful catch back at the tower. Unfortunately, it seems as though we lost the attitude control of the ship. We are standing by as we listen in with the teams on the nets to understand what information we're able to provide you. We will provide that as soon as we are able, but it's pretty incredible to take a moment and see the booster just behind us. Certainly a different view than last time.
And at this point, we've essentially lost contact with the ship. We're no longer receiving telemetry at this moment. So we were only about 20 seconds away or so from the end of that ship ascent burn. We saw several of the engines start to cut out. Once you lose enough of those center engines, you're going to lose attitude control. And so we did see the ship start to go into a spin. And at this point, we have lost contact with the ship. So we're going to listen in for a little bit. I think it's pretty obvious we're not going to continue the rest of the mission today, but just give us a couple more minutes. We'll bring you more information as it comes in. All right, so coming back with you real quick. So can confirm we did lose contact with the ship. Unfortunately, this happened last time too, so we've got some practice at this now. We've got a lot of measures in place, like debris response areas where we coordinate very closely with air traffic control. We have a lot of measures put before we ever launch a rocket to make sure that we're keeping the public safe. Those worked last time, and they're actively in work right now. So just to recap real quick, everything we saw, we lifted off right at the top of our window, essentially at 5:30 p.m. Central Time. Booster was able to get us all the way up into space, made its way back here. It's sitting on the tower right behind us, our third ever catch. Starship ignited all 6 of its Raptor engines. It was just about 20 or 30 seconds away. We'll get exact times from the end of its ascent burn when we started to see some engines go out on ship, eventually lost attitude control, and then lost contact with the ship shortly after. So obviously a lot to go through, a lot to dig through. We're going to go right at it. The primary reason we do these flight tests is to learn. We have some more to learn about this vehicle, but we're going to be right back here in the not too distant future, and we're going to get a ship to space.
Yeah, you're absolutely right. We fly to learn, and we're learning a lot. And as is the case with developmental programs such as the Starship program, progress isn't always linear. So at this point, we're going to close out our webcast for the day. But before we do, we'd like to give a shout out to our viewers, of course, as well as our partners, both here in Cameron County and around the world. Now, once we know more about the mission today, we'll provide you with updates on SpaceX.com as well as at SpaceX on X. As always, thanks for watching, and we'll see you next time.